Hi guys, it's Nick DeFilippo here, and in this video I want to show you how to use the analog input on the Arduino to change how quickly an LED is going to blink. Now what we're going to do is we're going to use a potentiometer, and we're going to read that in with the analog input. So first let's talk about what a potentiometer is and does. So I have different potentiometers here. They come in different sizes and shapes. So you have some little ones that require something sharp to go in order to turn it, and you have bigger ones that you can turn with your hand. So as you turn the knob, the resistance in a potentiometer is going to change. So it's a variable resistor. Now on most of them, or all of them, you'll see these three terminals. These outside two terminals have a fixed resistance. So what that means is if I connect my multimeter to them, it's always going to show you what the potentiometer is rated for. So this one right here, it's 100K, and you see it's 100 kilo ohms right there, and it's not going to matter if I turn this knob or not. Now if I connect one of them, it doesn't matter which one, to the middle terminal, which is the wiper, you can see as I turn this, the resistance is going to vary. And now the resistance is going to vary between the 0 ohms and what the potentiometer was rated for at the other side, which is 100 kilo ohms. So this particular resistor right here, it's very coarse, so it's a one-turn potentiometer. So between 0 and 100 ohms is only mapped to one turn of this potentiometer. So you have to turn it very slowly to get a slight change in the resistance. Now they sell nicer potentiometers, which are 10-turn potentiometers like this one right here. So these are my two outer terminals, and it's going to show 99.2, so regardless if I turn it, it's not going to change. And then if I connect it to the wiper, the resistance changes much more slowly because I have 10 complete turns to go from 0 to 100 kilo ohms, which is quite nice, and it's a lot more, you have a lot more fine adjustment over this type of with this type of potentiometer. So let's take a quick look at the circuit that we're going to make up. And in this circuit we have our Arduino with 5 volts that goes into one side of the potentiometer. Our ground goes into the other side of the potentiometer. And these two sides are the two terminals that have the fixed resistance. The wiper is going to go into analog pin 0. And for me, I have this external LED that's connected to pin 13. Again, just to make it easier for you guys to see. And if you don't have an external LED, pin 13 is going to be connected to the onboard LED. Now, when we connect 5 volts in ground to the two sides of the fixed resistance of a potentiometer, what we're doing is we're creating a voltage dividing circuit, and we're reading in that output voltage into analog 0. Now, what is a voltage dividing circuit? Really quickly, a voltage dividing circuit takes in some voltage, some V in our case this is 5 volts, and it goes through two resistors. We have R1 right here, and we have R2 right here, and this is connected to ground. So the output that we're interested in, that this is going on internally in the potentiometer, and our output is between these two resistors, and this is our V out. Now, there's an equation for this in general that is good to know if you're dealing with electronics. It really doesn't come into play for us in this video, but it's good to know. So this V output in a voltage dividing circuit, so a voltage dividing circuit, V out is going to be equal to your input voltage, so V in, times this the voltage that's over this, times this resistance, R2. So V in times R2 over the total resistance, so R1 plus R2. And this is a R2. That's a really bad too. Put it in a different color. This is R2. So this is the voltage that we're getting at our output. It can be derived, but again, it doesn't really affect us that much. It's just good to be introduced to this. So this is what I just had shown you in fritzing. I have the 5 volts in ground connected to the two sides of this 5K potentiometer, and here's my external LED. So let's code up a little bit of what we're trying to do. So the first thing we want to do, we want to declare our LED pin, and this is again pin 13. So this is with the onboard LED, and in our setup we want to say that our pin mode of our LED pin is going to be an output. And the other thing I want to do, I want to begin a serial communication at baud rate 9600, so we can print out what we're receiving from this potentiometer. So serial.begin 9600. What I want to do is I want to blink an LED based on how this potentiometer is turned. So to blink an LED, we want to turn our LED pin high. We want to delay for some amount of time. We want to turn our LED pin low. And again, we want to delay for some amount of time. Now this amount of time is going to be determined by the potentiometer. So we're going to need a new value. I'm going to call this int, and this is going to be our A to D data. So our A to D data is going to be equal to analog read, and we're connected to pin 0. So this is analog read A0. So this A to D, this is going to read value in, read in a value between 0 and 1023. Now this might seem like it's a weird number, but this is why. If I go back to this, for our A to D, Arduino is a 10-bit. And because it's 10-bit, the A to D is given by 2 to the n, which is equal to 2 to the 10. And if you go 2 to the 10, this is equal to 1024. Now, because we're going from 0 and we're basing everything off 0, we're not going to be 0 to 1024 because that would be 1025 different numbers. So we're going to subtract 1 from this, and we're going to go from 0 to 1023. And this is how we get the A to D value. Is at 5 volts, it's going to be 1023. At 0 volts, it's going to be 0. Another thing we need to worry about when we're doing the A to D is the resolution. It doesn't matter for this particular example, but our resolution is the smallest amount of voltage that we can detect a change in. So our resolution when we do A to D, our resolution is going to be equal to the range divided by 2 to the n. And for us, our range, if we leave all our settings default, our range is going to be 5 volts because the reference is 5 volts on the Arduino. So it's 5 minus 0, 0 is ground, divided by 2 to the n. So it's going to be divided by 1024. And if we do 5 divided by 1024, we get, this is equal to 0.00488 volts, or 4.88 millivolts. So this is the resolution we have when we're dealing with an Arduino. It's 4.88 millivolts, and this is the smallest change in voltage that we're able to detect that will make this A to D increment up or down. So let's look at a quick example that might help illustrate this point if all these numbers are just sounding sort of out there. And for this example, we're going to look at a 2-bit A to D converter. Now, a 2-bit A to D converter is not very useful, but it illustrates the point very nicely that I'm trying to make. So if we have two lines, we have a x-axis and we have a y-axis. Our x-axis is going to be the input voltage, voltage, and our y-axis is going to be the A to D values. Our A to D values are going to be this right here. So it's going to be 2 squared, because this is only a 2-bit A to D converter. So this is equal to 4. And our A to D values, because we have to subtract 1, are going to be 0 to 3. So that means right here we're going to have 0, we're going to have 1, we're going to have 2, and we're going to have 3. Now, the input voltage, we're going to go from 0 to 5 volts, and we're going to break this up into our resolution. So our resolution is going to be equal to our range, which is 5 volts, divided by this 2 squared. So this is going to be equal to 5 over 4, and this is going to be equal to 1.25. So our resolution, with a 2-bit A to D converter, the best we can detect is 1.25 volts. So if we break that up right here, this is 1.25. This one right here is going to be 2.5. And this one right here is going to be 3.75. So what this means is if we get anything between 0 and 1.25 volts, we're going to get 0 on this A to D converter. If we get anything from 1.25 to 2.5 volts, we're going to read 1 on this A to D converter. If we get anything from 2.5 to 3.75, we're going to read a 2 on this A to D converter. And if we read anything from 3.75 to 5 volts, we're going to read a 3 on this A to D converter. And this same concept applies to this Arduino, but the Arduino, since it's 10-bit, has 1024 steps, and instead of a 1.25 volt resolution, it's going to increment at every 4.88 millivolts. So this A to D data, let's print this out in our serial line. So we have serial.println, and we're going to print out A to D data. Now this is going to be a number between 0 and 1023. If we put this number in right here, we're going to be delaying between 0 and about 1 second. But I want to scale this a little bit. I want to scale this, well, let's put that in first and then we'll scale it. So if I do delay A to D data right here, and I upload it to my board, analog in. You're going to see it upload to my board. If I open my serial monitor, I'm displaying 0. As I turn my potentiometer, my serial monitor is going to change. The LED is going to blink, and as I keep turning it, the amount of this analog input is going to keep going up. It's going to go slower because of the delay, but it's going to go all the way up until the other side, which is 1023. So one thing you'll notice if you're at 0, or if you're at a very fast refresh rate, it takes a while. It sort of looks like the LED right there at 11, 10, 11. The LED is not blinking at all, and that's because our human eye can't perceive the LED blinking fast enough. So maybe we can start to see it blinking. I don't know, I like maybe 30. Or 20. You can sort of see it flickering. So I want to scale my range between 20 milliseconds of a delay and 1 second of a delay. So right here, I'm going to define a new variable, and this is going to be my A to D data range. And my A to D data range is going to be equal to this command called map, and we're going to map this A to D data, which goes from 0 to 1023, to my new values, which is going to be 20 to 1000. So this takes the value you want to map. It goes from the low value, then it goes the low value from, then it goes from the low value the high value from. So these are the high and the low value are the two values that can be in between, and then you want to map it to the third and the fourth and fifth arguments, this 20 and 1000. So this is going to be the low value 2 and the high value 2. So what this is pretty much saying is if I get a 0, I'm going to change it to a 20. If I have a 1023, I'm going to change it to a 1000. Anything in between a 0 and a 1023 is going to be mapped accordingly between 20 and 1000, and then I'm going to put it into this delay. So if I upload this to my Arduino board, if I upload to my Arduino board, what we're going to see is if I look at a serial monitor, the lowest value that I can now have well, that's why. I changed this to A to D data range, but I didn't change my delay to A to D data range. So if I upload it this time, and I look at my serial monitor, when I'm at 0, this is still going to be blinking. It's not going to be off now. And when I slowly turn it up, it's going to blink until it has a 1 second on and off.